Hi folks, we're going to talk about phase changes today. So you have already filled out page 1, and then we skipped ahead over to page 4. We're going to take care of some of the easy stuff that we could have done in class, but this will be faster and it's fine. I'm going to start with ordering the phases from coldest to warmest. We're going to stick with the 3 main ones. Nothing really all that surprising here. Solid, then liquid, that's faster, then gas. But this is where things are a little bit more vocab-based. As you can see, we've talked about a bunch of reactions, but we haven't discussed really at all about the heat given off by reactions or physical changes. So we're going to start by talking about physical changes. We'll deal with heat given off by reactions, actually, in the next unit. Okay? So first, name some processes. First, let's just go with the basics. What is it called when a substance goes from solid to liquid? Now, you might call it melting. You might call it melting, but there's also a more technical term for it. It is also called fusion. Now, that is not to refer to nuclear fusion, which is when 2 nuclei fuse together and make a new nucleus. That's something we'll talk about in June when we do nuclear chemistry. But fusion is a synonym for melting. So I want you to understand that that's definitely a possibility, that you'll see the word fusion instead of melting. That's going to become important later in this unit. Liquid to solid is known as, well, freezing, but it also has a more technical name, which you might see used, that is solidification. Liquid to gas you may know as boiling, but again, we're going to have another potentially more technical, I guess, term, which is vaporization. Now, it is important to note that boiling is vaporization. It is not evaporation. That was the whole vapor pressure thing that we talked about last unit. So that is just when you are not at the boiling point, but there is some vapor and some liquid. So that is evaporation. Vaporization is a true boiling. Gas to liquid, you refer to that as condensation, and that is pretty much what you will see it always called. There is a more technical term. You might think it'd be liquefaction, but because English is English, it's not liquefaction. It is actually liquefaction, and not only does that change some of the orders of the letters at the end, it actually changes this to an E. It's not liquefaction, but again, you'll rarely see that. Now, solid to gas, going directly from a solid to a gas, is a little bit different. Not a phase change you necessarily have always thought about. We have talked about it a couple times before, and that is sublimation. You remember one thing out there that does sublimation, that goes directly from solid to gas without stopping at the liquid phase. Don't pass go, do not collect $200. So I want you to write down one example of something that sublimes, something that undergoes sublimation. And then gas to solid, you leave that. That'll be part of your homework. Gas to solid will be, the term for that is deposition. You can think about that being a gas depositing as a solid, and really that can happen. I've seen that before. In certain reactions you can do, and certain materials will go directly from gas to solid. Now, if you go to page 3, I want you to draw a graphical representation, and this is not very difficult to do. What I'd like you to do is I'd like you to make 3 spots. So gas, solid, gas, liquid. I want you to put a circle around each one. One day I'll figure out how to do the drawing tools on this. I know there's a way to do it. I don't know. It's around here somewhere. But I think because I'm sharing the screen, it's not so easy to do. Anyway, I'll look into it another time. I want you to draw a circle around each of these. And then I want you to draw an arrow. Like from here to here with an arrowhead on it, like that. Pointing gas going to the liquid circle. And then above it, you would write, I know the arrow you can't see, but above it, you would write gas going to liquid, which would be condensation. All right, maybe you'd write it in a little bit of a smaller font. That would be over the arrow that goes from gas to liquid. And then I want you to do another one from liquid to gas, and liquid to solid, and solid to liquid, and gas to solid, and solid to gas. I want you to do all the possible combinations. So draw arrows, make sure you have a direction on that arrow, and then right above it or below it, the phase change associated with that arrow. And that is homework, so you've got to go ahead and do that. Okay, that brings me to phase diagrams. Phase diagrams are kind of cool because this takes into account, as you take a look at this graph here, you can see that we've got temperature and pressure on the X and Y axes, and you can actually change the phase based on the amount of pressure or the temperature that you have. Temperature, you guys know. So if you go trace this along at 1 atmosphere, you will see that you have solid. This is all solid. Here's the liquid and then gas. And every single phase diagram for every material will look this way. Gases will be on the left. I'm sorry, solid will be on the left, gas to the right, liquid in the middle, and also elevated. So there's a spot where it's just gas and solid down here, and we'll go to that in a second. Well, take a look here. As you march along at 1 atmosphere, you will see that, well, here's 0.01 degrees Celsius. This graph is not to scale. And we'll do our definitions in a minute, but I want you to just look at this thing. You go from ice, solid, to liquid, water. So this line right here represents melting or freezing, depending on which direction you're moving. But at 1 atmosphere, that happens at 0 Celsius. And you march along, okay, and now we're here at the next line, which is another phase change, this black line. And that occurs, as you can drop down, it drops down for you, 100 degrees Celsius. And that's the boiling point for water when you're at 1 atmosphere. And maybe not surprising, that's called the normal melting point and the normal boiling point. But you might see that as you change the pressure, where this happens changes. Okay? And look at this. If you're below 0.006 atmospheres and you're down at like 0.001 atmospheres, check it out. You actually take ice directly into steam at these very low temperatures. There's sublimation of ice. Actually happens. Now, I don't know if you have. I've had it before. Have you ever been to the science, any science museum and bought that freeze-dried ice cream? Or freeze-dried anything? Well, freeze-drying is literally that. They freeze it, and then they pull a vacuum on it, and it sublimes all of the water out as solid going to gas, leaving all these little air holes in there. And that's why freeze-dried food feels the way it does in your mouth. Pretty cool. So let's read this here. And now the truth is we can change how these phases go by playing with the temperature and pressure. All right, that's what I said already. What do you think the effect of decreased pressure will be on a boiling point? Well, you can look at the graph, but you know this already from Teichbelach. If you decrease the pressure, the boiling point goes down. Just like Mount Everest, we can decrease pressure way below that just using a vacuum pump, and I will show you that in class. I think that's a pretty neat demonstration to take a look at. Make sure I'm not bucking up against any time limits. Doesn't look like I am yet. Should be soon. All right, so what does this graph mean? Lines, as we talked about already, they represent phase changes. Black lines. There'll be lines on there, but there you go. So now we've already kind of defined this, but we'll do it again. Normal boiling point is the boiling point. Boiling point at 1 atmosphere. And so the normal freezing point is, therefore, of course, the freezing point at 1 atmosphere. Triple point's really cool. Take a look at the triple point. Oop, we've only have 30 seconds left. I'll have to save the triple point to the next video. Cliffhanger. All right, go check the next video out.